Craig Whitmore is the speaker. He's going to be talking about two middle school tools that he's used. Well, not middle school tools, but he teaches middle school programming using Chipmunk BASIC and Scratch.
Yes.
And without further ado, I'm going to detach. You're going to hook this up to you so you can be videotaped.
Very good.
And heard and all that sort of good stuff. And take over.
Okay. Well, good morning. Thank you all for coming. Wow. Blown away. A lot of people. Yes, please forgive the sweat and the drinking of the water. I should have left the keynote just a few seconds earlier or minutes earlier and ran out to my car and got my things. And I debated about whether or not I should even get my things, since almost everyone has a laptop and almost everyone's probably hooked into online. So anyway, my name is Craig Whitmore, and I am a 7th grade science teacher at a middle school in Bakersfield, California. When I was hired to teach science, I was told that I needed to teach 3 classes of science and then 3 elective classes. And I was coming from being a high school teacher, where in high school you're pretty much told what you're going to do. They say do this, this, this. Here's what you do. In middle school, when I got there, they said, what do you want to do? I said, really? I can do whatever I want. Yeah, what do you want to do? So one of the classes I proposed and they said yes to was a computer programming class. And so this is kind of what's come out of that in the past 7 years. I do have a handout. I have 2 handouts, actually. I have a copy of this with space for notes. So if you'd like one of these, I'll just start passing them around, and you are more than welcome to take one. This is what I debated. I was taking notes on my laptop during the keynote, so sure, thank you. I didn't know if you all would prefer paper or not. And then this is the handout of the course. This has a semester length, almost every worksheet that we use. They are shrunk down in size. I couldn't fit them all in normal size pages in something that my school would let me copy off, although I didn't ask them. But they would not take up a full book. So they're shrunk down to about 1/4 of the size. And this is just for you to see today. You can download all of the full-size ones on the CSTA website, or you can go to my school website and download them from there as well. Or if you just want to enlarge them, there you go. So I'll pass these around as well. And I'm fairly certain I made enough of these this time. I had an issue with that at a time before. Thank you. And thank you so much, Carl. Thank you, Carl. And let me know if we run out. We'll definitely have more. OK, so, oh, thank you. Thank you, thank you. Whew, I'm not sure where you guys parked, but I parked a long ways away. OK, as I said, I teach 7th grade science, and computer programming is really a side thing more. OK, let's see here. To be discussed today, here's what I sort of envisioned going over. And this is my first year ever coming to the CSIT conference. I signed up with CSTA as a free member a number of years ago because it was free, and I was teaching computer science. And I'm still sort of figuring out what all that means. How many of you here are middle school, elementary teachers? You know, that's awesome. Cool. I was afraid I'd be the only one. Any high school teachers? Thank you so much, Carl. And college teacher, professor, peoples? Others who don't? OK, awesome. Very cool. All right, well, so here's what I'd like to discuss. The goal of the course that I teach, why I use BASIC and Scratch, the curriculum, just kind of go over it, answer any questions you might have, and then show some examples of student work. Real quickly, some of the things we use in the course I do, and I try and be very visual with the students. They're middle school students, 12, 13-year-old boys and girls. They don't all want to be in my course. Some of them didn't sign up for it. They just got put in it. Some of them, their friends said, oh, I'm going to take this class. Why don't you come take it? Some of them love computers. Some of them hate computers. So we try and make it as interactive and as interesting as possible. We use Chipmunk BASIC, which is a little mouse-looking thing up in the corner on the right-hand side. Scratch is a little cat. How many of you guys are familiar with Scratch? You guys, sorry. You professional people. OK, so Scratch. And then who knows what this would be? What's an example of? Yes? ASCII art. Yes, we go over ASCII art in the course. It's an old style form of art, and it's still alive on the web. And the kids really get into it. And then Cave of Time, these are choose your own adventure books. I brought some examples if you want to see an actual physical book of one. But those have been out for I don't know, 30 years or so, when they're making a comeback, and they really tie in well to what we do in the course. We do go over Zork a little bit in my course. How many of you ever played Zork? Is that a familiar thing? My students get the chance to play Zork in class. I give them maps. I give them hint books. I give them a cheater how to get through it in 100 commands or whatever, and they just love that. And then who's this guy? Okay, so Halo Master Chief. It's an animated GIF or GIF or however you're supposed to say that, but it's an animated picture, and we use those when we do Scratch. And you'd be surprised how many students want to make games out of the Master Chief running back and forth, kind of Halo style. So those are some of the things we use in my class. The goal of the course. And this was not the goal when I started the course. The goal when I started the course was just to teach an elective course that wouldn't get me fired for my new job at my middle school. But really, it's kind of, as 7 years have gone by, this is sort of what's evolved. It's to introduce students to computer programming in a way that encourages them to continue in it. And I'd like to just quickly go over a couple parts of that. The first part is to introduce. This is really an introductory course. I'm assuming that none of the students have any experience whatsoever with programming. They wouldn't know programming if it came up and bit them on the nose. They largely think computers are for typing up papers to turn in late, to get online, to research something, or to text back and forth on their phone. That's pretty much their experience with computers. I've been told by someone much wiser than I am that students today don't necessarily know more about computers than we do, although sometimes it feels that way, but that they just don't care if they break anything. So they'll just plunk away, they'll hit things, they'll click on things, and they don't care if they break it because it's not theirs, and they don't have the experience that we probably had of the computer dying and having to restart and all those different things. And if you don't treat the computer nicely, it's not going to do what you want. They just don't care. They just kind of do whatever they can, and eventually they get it to do what they want it to do. So, but as far as computer programming, they really have no idea what that is. To introduce students, I think it's important to remember that we're dealing with students, and some facts about students that I've kind of learned over the years is that all students are experts in something, even though they have no clue what programming is. And in fact, some of them really don't know much about computers. They might think they do, but they really don't. They are experts in other things. And if you talk to them, you absolutely find out, those little hot buttons, those little topics in their life that they know a lot about. And some of them are even interesting to me as a person. Some of them are not. Some of them are just kind of, okay, whatever, never want to know any more about that in my life. But some of them are cross boundaries. Number two, students like things about themselves. They like an assignment if it involves themselves. Their name, their friends, their hobbies, their family. If you can bring something to the table that involves them in their life, then they tend to buy into that more. And number three is that students like playing games. They just love playing games. If it's online, mini-clip, addicting games, whatever, all those other ones that I don't know that much about, because I like playing games, but I'd rather read a book. I'm just kind of, I don't know. I like teaching computers. I like teaching technology. My phone is one of those old flip razor phones. I don't text. I don't do I don't do any of that stuff. I mean, I just don't. But the students like playing games. They like being involved online. So like things about themselves, and they're experts in something. Computer programming, a little confession here, I am not a computer programmer. I'm coming to this from the teacher side. I tried electrical engineering my first year in college. Very quickly found out that was not what I was created for. Did not do very well in a couple classes and quickly decided to go a different direction. I did take one computer class. I think it was called Fortran 77. So that's my experience. How are you taking Fortran 77? Is that, wow, okay. You probably remember things from it. I have no clue what it was about. The only experience I really have is when I was about 12 or 13 years old, I spent probably 3 to 5 hours a day programming in BASIC on a little Atari 800 at my parents' house. It was hooked up to a TV. And I just loved that. It was fun. It was exciting. Some of it was playing games. Some of it was creating games. Some of it was creating book reports, seeing what I could make, seeing what I could do. And I still remember a lot of those things that I just kind of fell into back in that day. And so that's been my experience with programming. So other than that, I'm a little clueless on what computer programming might be. But the last part of this is to introduce students to computer programming in a way that encourages them to continue in it. And about this, I think it's important to look at what application or language they're being taught for computer programming. One thing that I feel is that it needs to be easy enough for kids who have zero experience to understand it, to be able to do it. This way, thank you. It needs to not be so, what's the word, esoteric or exoteric. It needs not to be so different from what they're used to that it would take them years and years to figure it out, to know it, to be able to feel like they've accomplished something in it. And number two, it needs to be interesting enough for the ones who didn't sign up for the class. For the ones who signed up because their friends did, or they didn't sign up and the deans just put them in there, or they got transferred into the class, or for whatever reason they really didn't want to be there. Because you do have those kids, especially in the middle school, and I'm sure in the high school too. So, okay. So the ones I use are Chipmunk BASIC, and this is the homepage from Chipmunk BASIC, and the address is up there and it's in your notes. Ron Nicholson is the one who's made it, created it. It works on for the Macs, it works for Windows, and I believe Linux and Windows. On Windows, it doesn't have sound and it doesn't have graphics because on the Mac, he wrote it specifically for the Mac, and then he ported it to Windows, is my understanding, unless he's in here and he can tell me otherwise. But the graphics and sound are different on Windows, and so it's not really cross-compatible that way. The Scratch webpage, Scratch MIT EDU. They're both free, which is mainly why I've chosen these, and they're both fairly easy for students to buy in and learn the language, to be able to talk in that language and to be able to program in it. Scratch has really taken off. I only found out about it, I think it was a year ago Christmas, so maybe a year and a half ago. I know it hasn't been out all that long. It already has more than 1 million projects from around the world, as the cat there is saying. And there's some really interesting ones, and there's a whole educator webpage for it. There's a whole discussion and support deal that's involved with it. So if you want to get into Scratch, you absolutely can, and it's pretty easy. You basically just show it to the kids and have fun. I mean, I'll show you what I do, which is a little more structured than that, but really you can just give it to them and say, learn something, have fun, show me what you made. They tend to like it a lot. Okay, another reason, I looked at a few other languages, which again, I didn't know coming in at all. Squeak is one of them. I'm told that Scratch is based on Squeak. I really don't know what that means, but to me it just seemed too complex. Python was another one I've heard about. Never programmed, never tried it. Again, I looked at it and thought, what? I just can't get it. If I can't get it, I feel like the students will have a hard time. If you do understand, and please don't think that I'm saying you shouldn't do this. My experience is 7 years working with students and trying to teach them computer programming that I'm trying to learn myself. But if you understand it, and if you have a method of doing that, that's great. For me, wasn't something that I could feasibly do. Another one was Alice. I really looked at Alice at the same time I was looking at Scratch and thought about using it as instead of Scratch. The problem that I had with it was that it was complex. It's not as complex as some of the other languages. It doesn't have some of the problems with words that aren't English. What does that word mean? It's fairly better that way. But when I had some of my student aides, try it on the computers we had at our school, it wouldn't run. It bogged down so much that it just crashed the computer. You need at least a computer that's earlier than 8 years old to run it, and we don't have those, and we're not looking to get those. So for me, that wasn't something that would happen right away. I could see using any of those languages as an advanced programming one at our school, but at this point, I'm the only one who's doing this at my school, and it's not going to happen pretty soon. So we'll see if in the future it does. Chipmunk BASIC. This is what not the format. This is what the programming page looks like. If you've ever programmed in BASIC, it's almost exactly like what it used to be back in the 80s. For Scratch, here's an example program real quickly. This is one that students tend to like. We do this at the beginning of my class every year, and I remember doing this when I was their age. Remember these programs? Yeah. I added a little one in here. And you do it in class. You tell them, okay, now hit return, and oh, whoa, there, the gasps go up from them. They just love it. Yes?
What's the length of your class? How long is it?
It's a semester-length class, and I generally do a quarter of Chipmunk BASIC. I do some other things. I do like the history of computers. There it goes. Just prints hello, hello. Or we do their name, and they see their name flash across the screen a bazillion times, and they just love that. They just think that's the best thing in the world. And I'm like, really? Really? You got your phone, and you got all these games, and really? But they do seem to like that a lot. So and we do a quarter of Chipmunk, plus some introductory stuff, parts of a computer, history of computers, futuristic computers. And then the second quarter is all in Scratch, pretty much. So, and it does tend to work out fairly well. So, and then, let's see what else I have here. For Scratch, I don't believe I have this as just an example program. This is one that's already loaded up in the Scratch environment when you put it on your computer, and it's available free from the MIT website. This is the area you would snap the little bricks together to program. You drag them from the different drawers over here on the left-hand side. This is the looks drawer. There's motion, sound, control, sensing, operators. There's some fairly complex ones that I've never tried or gotten into and really don't know how to use totally well. There's some that involve sensors, where you can connect a sensor up to your computer, and if the sensor sends a signal, then it will do something. It'll listen to voices. If you make sounds, it'll sense the sound level, and you can actually make a game you control with how loud you are in class. That's a lot of fun. You got all these, make noises. It lets you record your own voice. It lets you import pictures from anywhere. It's really nice. Anyway, so this is where you would put all the blocks together to program. You can have different, I don't know what these are called. You can have consecutive or parallel command lines going at the same time, if that makes sense. I may be saying that wrong. The different sprites you use, it really is based on sprites. And then the stage. Lots of different things you can bring into this. So that's what Scratch would look like. Questions so far? Am I talking too quickly? Okay, I'm finally cooling down. I'm feeling like... Okay, basic curriculum. So here's what we do for basic. It lasts about a quarter, about 10 weeks. We use about 6 worksheets to introduce the code, the concepts. And if in the blue packet, again, these are shrunk down, there is a sort of a table of contents that shows you what I go through in the course for the first quarter. And then if you flip the page over, you'll see the actual worksheets. These are really for printing off and giving to the students. In some cases, they're doubled up, where you just print one copy and cut it in half, because our school likes to save money. Some of them are worksheets the students would fill out, and as they fill it out, they learn the programming concepts. And then the next day, usually I would give them a program to type in and modify. The first example program, there's not page numbers, I apologize for that, is just called printing practice. So they get it to print out, see Tom and Mary are running, run Tom, run Mary, Tom and Mary like running. Okay, just some simple stuff, or they can do the one about, I will, what is that? Oh, Dr. Seuss, I will not eat them with a mouse. So they would program this in, and then they would make changes to it. I usually have them make one modification, maybe 2 modifications, and they save it. And it is very simple. But for students who've never done this before, even in BASIC, it amazes them that they type something in, they hit return, and then it's still there. Or they change it. Well, it didn't change it. See it up on the top, it's still there. You have to tell them, well, in BASIC, it's a little bit different. It's like an adding machine. You see a record of what you've done, but just because it's still showing you what you did in the past, it doesn't mean you haven't changed it. They kind of struggle with some of those concepts. Let's see. The students enter and modify 10 high-interest programs. The programs that I have them do, I don't always do exactly these. I change them as we go along sometimes. But the ones that seem to work the best, inputting with a prompt. Psychologist is where you talk to the computer. The computer would say, how are you today? And then on the Macs, you can actually have it say, how are you today? Which opens up a whole other can of worms when you have the computer talk. But it's kind of fun for them. And then they type in something and the computer comes back with, oh, that's too bad, or there's different funny things you can have the computer say. Mad Libs, where they enter a noun, a verb, and a color, and then it prints out something, just getting them used to printing out the format for that. We do ASCII art. I show them ASCII art. I have some ASCII art guides I've put together from some online sources, and I usually have these out if the students want to use them. We go over what is ASCII art, show them some different ideas. They'll try and make some of the different pictures, show them, oh goodness, I think it's Beck, a musician, has an ASCII art video called Black Tambourine, so I usually show them that part of the video, where it's all ASCII art. It's really interesting, I think. And then they have a challenge. They have to create some ASCII art. They have to put their name in ASCII art. We go to some online sites and some good online sites, because there's some bad ones, where they figure out how to use it and make use of it. We do a number guessing game, a riddle game, a sing-along where they get the computer to sing out like the Scooby-Doo song or the Flintstones song. And again, they seem to really like that a lot. And then the end result is a text adventure game, including ASCII art, the students plan and implement on their own. We spend a little bit of time playing Zork. Like I mentioned, Zork is an old style text adventure game. It's available online for free for Windows and Mac. You can even play it online if you don't want to download it to your computer. And there's maps. There didn't used to be maps, but now there's maps, so you don't have to wander around aimlessly for months at a time trying to figure out where you're going in this underground world. The students really seem to like that, and they get an idea of what a text adventure game would be. So at the end of the course, they take what they've learned about programming, if then go to all those different things, print, and they put it together to make a game. I think I have some example games here to show you. Okay, and you can see that we have some ASCII art involved. There's a website that does this with any names you want. They're called figlets, I guess. And you type in the name, you say go, and it has about I don't know, 100 different styles of ASCII art fonts. Some students use them on reports and on science fair boards even after this class. They just think it's really interesting. So they incorporate some ASCII art. Let me click through this. And they have a variety of things. My mind's running ahead of me, my mouth, or my mouth's running ahead of my mind. A variety of requirements they have to meet for this game. They have to follow a basic format. They have to use some certain protocols. They use variables. They have to use a sound. They have to have so many ASCII art pictures. They especially want to use ASCII art pictures once they play Zork, because Zork has no pictures at all. It's all just words. And some of them really don't like that at all. They're, where are the pictures? Why is it just letters and words? So they really tend to like putting in ASCII art. These are some of the better examples. I do get students who don't like it that much and don't turn in very good examples. And it's an elective class, so I try and go easy on them because I realize, as long as they're trying the assignment, I know that it may just be that this isn't their thing. But most of them tend to like it. They play each other's games. They write little reports about each other's games. They make recommendations, kind of edit, re-edit, that sort of thing. Here's another one. I tried to take out the last names of the students, but some of them put them in, so I couldn't. Anyway, so a little mystery game. Yes?
So this Chipmunk BASIC, does it have the ability to do any vector graphics or other types of graphics?
It does. On the Mac it does.
Like in QBasic?
I'm not familiar. I've heard of QBasic. I know that on the Macintosh it does. On Windows, I don't believe there's a graphics element involved. I'd imagine there's other basics you could use that would have an easier way of doing graphics in Windows. It does, though. I can show you a couple things. Those are my notes. Let's see. Those are my kids. Games to post. No. Where did I put them? There they are. Chipmunk games to play. Yeah, what I do at the end of the course is I give the students a CD, a CDR that has what they've created during the course in a folder, and then it also has all the stuff we've used, so they can just put it in their computer at home, download it, and show their parents, keep going on if they want to. Some of the students tell me it doesn't work on their home computer. I don't understand why that is, because it works on my home computer, but I don't know. But yeah, there are graphics. Here's one. These are ones that I've made, created. This is this one here. So this is just a little move around, catch the ball game. Okay, I'm not very good. And you catch the ball and you get points. In the class, the students like playing these games. And then what we do after they've played them for a little while is I show them how to hack the games. So I tell them, okay, if you want to do really well, so they would list out the game, they would find the spot where it talks about the weight speed or how fast the chipmunk moves, and they would modify that, then play the game again, and all of a sudden they've got a bazillion points, and their friends are, how did you do that? And then they actually get in, because they like cheating at games, they really do. So there are some graphics. Let me see, this one is one that some of the students really enjoy. It's called spider art. You choose a background color, and basically you're a spider. That's the spider art. And you move around. Let me slow it down. It's going way fast. Whoops, wrong button there. So, and then you can do little art. You can change the colors around. That was supposed to be orange. Maybe that was orange. And then when you're done, you can take a picture of it and use it as your background screen. What we do is we have iBook laptops that are about 8 years old now, and I set each student up with their own account on the laptop. So, and we also run it in what's called Simple Finder, so they're pretty much locked down. They can't throw away Microsoft Word because they've done that before. They can't erase other people's work. They can't even throw anything out of the trash can or the recycle bin. But they can change their background screen, and then they only see it when they log on. So it's not like they're going to change their background screen and everyone else who comes into the class is going to see it. Anyway, so they would make something like this. They can put little characters. Let's see, the graphics characters it has some sprites built in to it. I don't know what the flying eyeballs are supposed to be about, but there's some flying eyeballs in it. And then there's some others that are, there's different ones. So, yes?
What's a sprite?
A sprite? Who would like to answer that question, class?
A sprite is an object.
Thank you.
Object-oriented programming, so like it's a thing that has properties and behaves in certain ways.
Thank you very much. I do know with graphics, I remember when I first tried to learn BASIC, you had to plot every single little point. Like if you wanted to draw, say, the chipmunk, that is going to be coming up right here. If you wanted to draw this chipmunk, you had to put every single little dot, every little black and brown and white dot in a place. And when you wanted to move it, you had to move every little dot. And that was horrible. But what sprites do is that the thing's considered as a whole object. So when you tell it to move, it moves as a whole object. It's flicker free. It doesn't have those kind of issues. That's my understanding of sprites. So. Okay, so it does have a few graphics things that you can do with it. I used to have the students program graphics games when I was just doing Chipmunk Basic. For a quarter-length course, there really isn't enough time for them to get into graphics unless they already understand graphics and the coordinate axis and all those different things. Most of them can't get it. I've had a few students who have taken the class 2 or 3 times because we do it in summer school as well. So 5th graders would take it in 6th grade. They take it in their 6th grade year, and by the time they get to 7th grade, they've already learned everything, so they wanted to go farther. So they've done some graphics, but largely we just stick to the text adventure game. Okay, so that's Chipmunk Basic that we go over, and then we get into Scratch. Okay, it's going to go through those. Let me just go on. I think I outsmarted myself here. Haunted house. Okay, so okay, Scratch curriculum. Okay, so for the Scratch curriculum, again, it lasts about 10 weeks. We use programs. I don't really give them worksheets for Scratch because it's very much self-explanatory. When they start getting into it, they'll start doing things you don't want them to do yet, and they'll just learn things. In fact, they'll probably teach you things. Most of the things I've learned that I think are really neat about Scratch, I've learned from students figuring them out. So I give them a game, a color printout of what I want them to put together. They put it together, and then they have to modify it. They have to change it. Once they've learned a certain amount of information, and we go through about, where's it at here? These would be the ones in the back that are more, I was going to say colorful. They're not in color, but they are more visual. These would be the games you would program. We go over creating your own sprite. Some of the students are really into art, and Scratch has a very nice paint program. You can do a lot of things in it. I don't know if it's bitmap or vector. I think it's bitmap, but it has a lot of capabilities as far as just a basic. I mean, I would probably pay money for it to be able to use it. It's in Scratch for free. So they create their own sprites. They change the graphic effects, the colors of the sprites. I'll show you this in a second if you'd like to see it. How to move and control the sprites, many options for that. We do something called name art, where we take the letters of their names and we make them bounce around the screen. And they, again, just love seeing their name on the screen. A maze, we get the sprites to run back and forth. They do what's called costume switching, where you have one view of the sprite, and then on the next costume, its leg is going backwards and its arm forward, and so when you switch rapidly, it looks like it's running. The students tend to like that. We do some gravity simulation. If you have it jump up and then fall down, they tend to like that. We import some online sprites. What happens when the ball hits the person? Is it going to go backwards? Interacting with sprites. Once we've done that, I have them do a retro game. I tell them, okay, you're going to pick a game like Pac-Man or Pong or Donkey Kong, which is really hard to do, or Frogger, and you're going to make it. And you can go online and find the pictures, or you can make them on your own, and your goal is to make that game, just to show them how far computer programming has come since the days when those games came out. And a lot of the students make very similar recreations of the games. They also get the idea that even though that game seems really simple, it's kind of complex. It takes them a couple weeks to do it, and they usually need some help. Usually it's not just you do it and show it to me. Usually it's, Mr. Whitmore, I need help. How do I do this? And so I'll come and help them, and then maybe they'll help their friend with the same thing. And then I tell them we don't always go through it again in the same way, but at some point they make an original game, a game they thought up, or maybe a game they play on Miniclip, or there's one called the Never-Ending Quiz or the Impossible Quiz, or and they like making those. I just tell them it has to be something that doesn't involve bullets or blood or zombies eating your face off. The kind of stuff I could show to the principal when he walks in the class and say, oh, come over here and see what the student's doing, Mr. Principal. So it has to be something that's okay for school. Then at the end, I either have them create an academic program, I have them plan out and then make a program about a class. Maybe it's a timeline for history. Maybe it's a simulation of a biology lab, which I haven't yet had any students make, but I made them because I teach biology and I wanted some simulations, so I made them in Scratch because they were really great. Or maybe it's going to be this last semester, I gave them a list of web terms, kind of Web 2.0 things, tag cloud, things that I barely have a grasp myself on, and I have them go and look it up online, and they do a presentation similar to PowerPoint, but they do it in Scratch, just to kind of show them what could happen. And some of them, sometimes they'll make it, you click on the word and it spins in and it does something. Sometimes it's just a list, but at least they have the chance to kind of see how it applies to academics as well. Okay, I think, okay, and my email address, it's on the website, but it's also on that handout. What I'd like to do real quickly is just show you some of the things that the students have made. Oh, I was just going to show you the, let's see, we'll go to some of these. This one, it's kind of fun doing this because some of the students that you get in your class may not be the typical computer programming types, right? Like you get students, like I said, who don't necessarily want to be there or didn't sign up for it or their friends signed up for it. But then some of them just surprise you. Over the 7 years, I've had a handful of students who just kind of blow me away in what they can do with computers and how quickly they pick it up. And what they teach me that I guess from this morning's keynote, I have these preconceived ideas about what you're supposed to do with a program, and then they just do something different. How'd you do that? Why did you do that? You know, but it's interesting. This is from a girl named Sabrina, and she made a Pong game, which, Pong, not too bad. It's a 2-player. Hers was interesting simply because every time you hit the ball, the speed goes up. There's sound somewhere here. And the score goes up, and she's got the score going. And she has these interesting colors that are just, I had another student make a Pong game. It was black and white, very boring. He was kind of the typical computer type guy that you would think of. And she makes this kind of colorful one. In Scratch, it's kind of nice if you want to change something, you can modify it on the fly. So if the game is being played, when you click the green flag, the game starts, and forever if up arrow's pressed, change Y by 15, so it involves math, it involves coordinate graphing, if-then statements, conditionals. So you click this, if you change it, it'll change for you on the fly. So now, I don't know which purple one I just changed. Looks like it was that one, because they're both purple. So now I can go really fast. So this was one that a student made. Again, in Scratch, you would click on a drawer. As you click on a drawer, you get different programming blocks. Some of them are very familiar if you program or teach programming. Others are a little different. There's the sensing ones that are interesting. There's one called What's Your Names, or you can ask whatever question you want. So basically, you can ask them to input data, and it'll store it as a variable. And then you can use that or manipulate it, which is a really nice addition they made. What else is here? Oh, loudness. And the sensing ones on the bottom. You can hook up sensors, which our school doesn't have, and control things through sensors. You can control things through your voice, the sound of your voice. So you can bring in some different elements to what you let the students do. Let me see. Would you like to see some other games they've made, or would you like me to show you some stuff about Scratch? What would be the...
Just basic how to start it.
How to start it? Okay. So, let's see, where can I move to? If I move over here, is that a little better? Okay, sorry, I keep bending down here. Okay, so for Scratch, when you load it up, it's going to look like this. Save the current project, no. Get out of that. This is what you get when you load it up. Little cat, Scratch, it's their logo. You would click on the drawers over here on the left-hand side, and you would pull bricks out. You can make it move 10 steps, and you can either double-click on the brick, and then it moves, or you can create a program when the green flag is clicked or when the space key is pressed, or you can use what are called broadcasts when I receive a certain broadcast. The basic way to do it is when the green flag is clicked. So when the green flag is clicked, move 10 steps. So every time you click the green flag, it's going to move 10 steps. And if you wanted to do it more than once, you can throw a forever loop in. So forever move 10 steps. So now when I click on it, it's going to get stuck over there on the side. Very nice block they have under motion is called if on edge bounce. So if you put an if on edge bounce block in, and again, you can show this to the students as you're doing it, and it just goes back and forth. You can tell it not to turn upside down by clicking this block. So now it's just going back and forth, left and right. And you can kind of see the way that game ideas develop from that. I mean, you could make up a game from this. You could tell it, hey, if I click on you, then do something, or you've got to avoid things that are falling, or lots of different ideas. You can modify the way it looks. If you go to costumes, there's 2 costumes here. Right now I'm just using one. If I want to go back to scripts and looks, I can tell it to switch to the next costume every time. So now it's sort of running kind of quickly. I might want to slow it down possibly, or add a wait block in there to make it not so jerky. And you can see it's going back and forth between both of them. If I want to edit a costume, I can click on Edit. And I can go in, and again, this paint editor is very nice. I can change the color of the cat. I can do a fill. I can paint in nothingness. I can paint in different colors. The students love making the cat different colors. I don't know why, but they do. So you can do interesting things like that. You can erase things. You can grab things. You can put text in, so the text can be part of your sprite. So now if I say run, it's going to look awfully weird. That's flashing blue and white. There's a camera. So if you want to, you can import a picture of yourself. Our laptops do not have cameras because they were built before cameras were put on laptops. But you could always bring in a video camera and plug in a little SD card and do that kind of thing and let the students put themselves. I've had students make programs. One took a picture of our class and then went around and took pictures of people's faces. And when you clicked on the people, their face would turn and go, ah, and make noises. Yeah. So. It's under costumes. Yes, it's under costumes. And this is the newer, this is the 1.4 version of Scratch. There was a 1.3 version that didn't have some of these things in it. I don't know if it had camera in there or not, but the latest one on their website is 1.4. You can paint your own things. Sounds, kids love this. You can record yourself saying something, or they can record you saying something in class without your knowledge. You can import things. One of the nice things about Scratch is it has just gobs and gobs of sounds and costumes that are included in the program. So for animal sounds, all of these different ones, goose, duck, there's a goose, crickets, and again, they just give them to you for free. So you can, when you download the program, you get all of these things. Students seem to have a lot more interesting ways of using them than I would ever think of. So you can import a sound, you can record yourself, you can import an MP3 off of the internet. Students don't seem to understand that they can't just download it from iTunes for free at school. But if they find some sound, some song available online, they can upload it to their Scratch program. So you can also, if you want, tell it to, which I won't do this too long, but you can tell it to play sounds. I think if I put it in here, it's going to stop every time. Let me see. There's play sound until done, or just play sound. And you can control what sound. You can record from here. This is the meow. When you start this class, if you're using, yeah, you'll hear that a lot when you first start Scratch with your students. You're like, oh, I can make sounds. And my students also tend to like, this sound. Let me get it for you really quickly here. Human. Footsteps, laugh, party noise. Oh, where is it at? It's a singing one. I don't know why they like it, but oh, they like it. Vocals. That's got to be, yeah, there it is. Nope. That's it. I think that's it. So I hear this about a dozen times in my class. Then you have the student who just wants to do this all the time. So you're walking around class and you hear this, and then it goes again, then it goes again, and at that point you're about ready to strangle a student. But they really do enjoy adding the sounds in there. Let me take it out. So that would be just a simple way to do a program. You can have it sense things. You can have it, let me see under motion here. I could tell it to point towards the mouse pointer, so it's going to follow me around. So now it's going to be like a little chase game. Let me zoom out here. In fact, here's the full screen version. So now it's going to chase me around. And I could tell it, if you catch me, then say the sound, so you don't hear it that much. Let's get out of that. Let's see, what else could I possibly show you here? For the sprites, you can paint your own sprites like I mentioned in the paint program. You can import sprites, the pictures that you want to use. There's also a little question mark. That means it just picks one randomly for you. You'll get students who click it like 100 times and they say, Mr. Whitmore, my computer's frozen. It won't stop. It won't let me do anything. Well, how many times did you click it? Oh, like 1,000. Okay, well, let's just take the battery out because you're going to be here all day long. The costumes, though, they have animals. Lots of different ones. They have multiple costumes. They have ones that you can have the students switch back and forth, so you can make a bat that flies around after your little mouse pointer, and it actually looks like it's flapping its wings. They like that idea. Lots of different animals in here. They've got fantasy costumes. They have letters. This works great for the name deal. So they would go through, they would find their letters of their names, they would click it, they would put it in. They would excuse me, tell it to pick a random direction, start moving. If it hits a side bounce, and draw a line after it, which might sound, I don't know if that sounds complex or not, but it's not very complex for Scratch. You can go to open here, save the current project. No, please no. You can look at their examples. And again, these are all put in there free. They have animations, playground, ideas, trampoline, aquarium. Some of these are games. And the students, one nice way to have the students learn about Scratch is just have them play the games that they have built into here. Some of these are frankly beyond me, but some of them the scrolling demo, I'll show you this one real quickly, is one that, and here's the programming code, so the students can see that and then they can play the game. It's a side scroller, and it basically scrolls, the character stays in one location. I talked to the students, remember playing Mario and all those things where Mario had to run and jump on Kukla or what, I don't know, whatever it was. Yeah, okay, well, does Mario ever move, or does he stay in the middle all the time and the background moves? Well, really, he stays in the middle and the background moves, and that's something that Scratch can do really well. So I show them how to make a scrolling, side-scrolling kind of a thing. The guy goes up and down, but he's really staying in the same place. So anyway, little games, and then they can modify the games. You'll get some students who try and turn in a game. Here's the game I made, look. And you're like, I've seen that game before, past 3 years. And so they just take it and they try and say it's theirs. But there are some really interesting ones. It makes it nice and easy to be able to get them into it. Another nice thing about Scratch is it allows you to share the games online. The students can't really do it unless they have an account, which I tell them not to make at school. But some of them will go home, talk to their parents, I hope, and make an account at home. All you have to do when you want to share a game is click on share this project online, and then it gives you the stuff to put in. And what I do is I put in my Scratch login and my password, and I usually give it the title. Here, I'll show you. I usually give the title the student's first name only, because I don't really want to put out their whole name online just for cyber security reasons. Let's see, did I already do these? Okay, here's some examples. These are some examples of some games that students have made that I posted online on the Scratch website, and they're just under my school name, Norris Middle School. So the students could go home, go to the Scratch website, and say, Mom, Dad, look what I made at school. And I only put up the ones that are really good, and the ones that work, and the ones that seem like they might be interesting to other people. So this is by a girl named Brittany, and she did all this art, and I had no idea she was doing this kind of stuff in the Paint editor until one day I just looked at her screen. Did you do that? How'd you do that? And I was amazed. So I don't know what the program really does. It's more of just a little story. But I thought the art was just fascinating. This was one, a student named Bryson, and he wanted to make a car driving game where the background moved towards you. It's an animated GIF or GIF where it just changes and looks like you're driving towards it. He didn't spend a lot of time making it all nice and finished, but the idea is if you hit something, you die, and you can control the car back and forth. So he really enjoyed doing that one. Let me see. Here's kind of apropos to the NBA Finals that just happened. Yeah, he made it up a year ago, so I guess he was precognition. Cat basketball. So the two cats, and they play basketball, and you control one of them, and you can move back and forth. He had a hard time with figuring out the basketball because you can't just have a bounce. At least he couldn't figure out how to make it bounce anywhere, and I couldn't really figure out how to take the time I had to help him do that. So the basketball always falls straight down, and when you press the shoot button, it always makes it. So it's really just a race to the basketball. But the feet are moving and the legs are moving, and this is a student who only worked with Scratch for about 8 weeks, and then kind of did it. And admittedly, it's one of the students in my class who was more into computer programming. But that just kind of gets me excited to think of what he might go on to in high school when he maybe tackles some more mature programming languages. Let's see a couple others. Asteroids is kind of a favorite one. So this one, I think it's a shield on the ship, and then you shoot the rocks, and they turn into little scatters. So kind of interesting. You can't die in this one, though. This one, you can die in. This reminded me a lot of what a friend made when I was in high school, and he was programming in Pascal, and he made an asteroids game. It's going to reset in a second. So he has little rocks moving back and forth, and you can shoot them, and then if you run into it, which it'll do in a second, you die. They love making things die, and blood splashing everywhere. There it dies. And you have a shield you can use, and then the rocks bounce off of you. So just a basic game, but interesting ideas. Yes?
Oh, well,
or did you?
Finish, I had a question after.
Yeah. Okay, go ahead. Yeah.
I'm wondering, since you get the opportunity to talk to other teachers, do you find that students transfer some of the stuff that they learn in this class into any of their other classes, say their math class or like?
You know, I haven't had any students who've come back to me and told me that they've used it in other ways. I don't know. I know that, I know for math, the graphing I think is helpful, the coordinate axis, those types of things, although Scratch, it doesn't always match up to what they do in their math class, and sometimes that might, confuse them. I haven't talked to a lot of the other teachers or gotten feedback on it. One thing I'm planning on doing at my school in this next year when we have like a fall festival is setting up a number of computers in the gym where they have a bunch of artwork displayed from the art classes and letting the students be there and show their games off too as people walk through. We haven't done that yet for logistic reasons and because the computers keep dying on us, but that's the plan for next year. So, yeah, sure, absolutely. Okay. Okay.
And some explicit teaching, and I actually think that if you were working back and forth with the math teacher, it's a really powerful and solid way to teach that because it's very fun.
And to reinforce between one and the other. Yeah, that's a great point. That is a good point. Pac-Man. Several Pac-Man games. Hannah's was pretty good. When you tell them they have to make all the little dots, they go, what? I got to make all the dots? They don't like that too much, but. So anyway, Pac-Man, what else do we have here? Oh, this was supposed to be Frogger. A student who, he likes buffaloes and he likes basketball and ninjas. So this is his version of Frogger. And I just recorded one playing of it. And he also likes Yoda. So when you win, Yoda comes and tries to get you and you got to make it across the rest of the game, which, would never sell, would never be a game that other people would probably download. But for that student, he really bought into it and he really enjoyed it and enjoyed learning about it. I thought this one was interesting. This was also from this last semester. This one, the idea is you have to get the ball down to the little square and it just keeps falling. And when it hits the purple, it resets. So you have to drag the little red pieces over and basically create like a little pathway, which there's only one way to do it, really. But the idea was really interesting. It's a kind of a game I could see someone developing, if it's not already out there, and putting online, addicting games or mini clips or something like that, where you could, feasibly, possibly at some point in your life, make money from something like that. And I tell the students, this is kind of fun, but at some point, you're probably, if you're going to continue in computer programming, you're going to get into a language, you're going to get into some stuff where you're going to make money, because that's kind of what you want. I mean, if you're just doing it for yourself for fun, that's great, but doesn't pay the bills. So anyway, that one was interesting. Let's see if there's any others here that are, well, that was the Pong game. What's this one? Oh, no. That was just a story game. This is actually a copy of what we do in our class. We make a target shooting game. They download some kind of an animated GIF, either a bird or the Master Chief or a UFO. I've got a whole bunch that I found and just put on my website. And then they have a little crosshairs and then they have to shoot it and then it falls down, kind of like the old Duck Hunt game. In fact, some of the students make Duck Hunt for their retro game. A little bird flying around, the dog pops out and laughs at you when you miss. The nice thing is that anything you find online, that's legal too, you can download the picture and use it in Scratch. So if you find a very nice background picture you want to use, you can use that. If you want to do the Muppets, you can find pictures of the Muppets. You can pull them into Scratch. You can delete the background. You can customize them however you want, and then you can use them in your program. So it's really wide open to whatever the students might be interested in, and kind of helps them to engage in the process. So, are there any questions? I know I just kind of ran through everything. Yes.
Basic, you said there's no graphics or sound on Windows.
I don't believe on Windows there is graphics or sound. I've only tried once or twice to use Chipmunk BASIC on Windows, and I was not able to figure out how to make it stop running when I did the name across the screen. There's some.
You think it may be operating system, and that might be different.
Yes, I think I think the operating system I don't know if there is a way to do it that's different, or if it just is not able to do it on Windows. I do know that there. Scratch is exactly the same across the board. It's the same on any computer. So yeah, Scratch is. If you were just going to start with something, I would say start with Scratch because the kids really get into it. I do enjoy starting with BASIC because it's something I like, and I see some students who really like it. Some students like to sit down typing away all day long, making these huge long programs. I brought some posters of the huge long programs. So there's a 3-page program. It's in size 8 font. It has, I don't know, about, what is that, 100 lines or something like that of code. And these students, they'll work on it for 5, 6, 7, 8 days. and you know, and they look forward to coming to class to sit down and type in this old, you know, programming language as long as they can, and to get their adventure, their game done. Not all the students are like that, but again, I would suggest just starting in Scratch, unless BASIC is something that you remember doing also, and you really enjoy it, and you really, you know, kind of have a feel for it. But Scratch, yeah, it works the same on both operating systems. In fact, our school, they just purchased some new laptops that are Unix based, so now I'm going to have to rethink what I do with BASIC, because I can't do some of the same stuff because it doesn't work the same on Windows or Unix. So, although I know there's other flavors of BASIC, and they probably, maybe they would work better. I just haven't looked into it, so I don't know.
Are these
Yes?
kids basically hunting and pecking, or are they actually typing?
Oh, for typing? Some of them are very good. We do have a typing elective at our school, and some of them have been through that, and others are just hunting and, yeah, hunt and peck. And some actually, I've been told, use their thumbs more than because of texting. Yes?
Much of this you've learned yourself and developed the program on your own. Where
Sure.
do you go for your professional growth? Who do you look to for mentoring?
Let me think about that.
Do you have a professional learning network?
Within computer programming, I use our district tech people a lot. I'll go and talk to them and ask them questions. We have a local Q chapter, computer using educators, I think it is, and our district tech person he was the past president of that, and so he's kind of really into that. He's one of the people I talk to. He's just our district person. We only have 3 people. We have 5 schools in our district and only 3 people, and really only 1 person that goes around and fixes stuff. But we're an all-Mac school in district, so we kind of get away with some of that. And then the computers start dying and we throw them away. So, but other questions or comments? I don't have all the know-how about this. Yes?
Yeah, well, I think so. Scratch is very good for teaching concepts, I think.
Okay.
Actually, I think BASIC, I've never taught it, but it looks interesting. I was wondering about the order of how you're teaching it, if you're doing BASIC first.
I usually do.
And Scratch second, or what's your rationale?
My rationale, I teach BASIC first because it's a simpler language. It's very English-based. You know, the words if, then. When you want to go to a line, you take go to. When you want to print or display, you say print. So it's something they're already used to, the English syntax. I also like it because they don't feel like they're, well, for instance, in math, when you're going to teach how to do calculus, you know, you start off with the hard way to do it, and then but there's an easier way. Let me show you that now. And so I think BASIC is the harder way to program, and you don't get quite as much out of it because you don't get the cool graphics and the neat stuff you can download off the internet, and you can't use sound so much. So we do that first, and then we go on to the kind of whiz-bang neat part of it. Most of them, after they've had Scratch, would not want to go back to BASIC, and you'd hear that cat meowing all day long when you're trying to do BASIC, and that's mainly my reason. Is I don't want to show them the cooler part before I show them, but I do think that the BASIC has a good it's a good foundation for them, and it teaches them it teaches them how to do loops, it teaches them how to do conditional statements and how to use variables in a program, which is something that's really good. It transfers over to Scratch. They program it differently, but the concepts are really the same. So, yes, comment. Okay, sure.
I'm just wondering, your middle school leads to a high school. Do they have programming at the high school that you feed into? And
You know, we don't have very good continuation. No, yeah, that's the word. We don't have very good. We feed into about 3 high schools. They all have some sort of programming classes. Usually it's in Flash or in web page design, but that's about it. They do some pretty good Flash stuff, from what I understand. Most of the high schools around us do, but we haven't really articulated well with them. Maybe
The last question.
1 or 2 more? Yeah, or 1, okay.
Given the previous 2 questions and comments, I am sort of curious. So if you feel like students, after taking Scratch, wouldn't go to BASIC, I'm wondering about the pipeline issue. So if they do go to high school, or say they go onto a program that allows them to code in C# or something like that.
Sure.
I mean, do you think that they wouldn't bother to go back to BASIC, that they'd be turned off with that?
I think that some of the students, they would probably never go back to BASIC once they realize how much more powerful the other programming languages are, because BASIC really isn't super powerful, but it is very simple. And I think some of them might at some point go back to it. I think mainly they would use the concepts they've learned to transfer over more.
I mean, the previous comment was that how Scratch, kids that are using would never go to BASIC.
Oh, so maybe they wouldn't go back to Scratch after it.
Would Scratch create a ceiling that, you know?
I don't know. If you want to talk afterwards, we have to. Yeah.
I apologize for having to end things, but people need to be able to get back to it. Happen next week. Thank our speaker.
And it's hard to find your way back. Thank you very much.